Hello everyone, welcome to Samadhan Life Science. Today our topic is Nernst equation from electrochemistry. Let's start with electrode potential, which is the potential difference between an electrode and the solution it dipped in. Now this comes from the tendency of an electrode to gain or lose electron. Now if we are considering a cell, then we will call the potential difference between two electrode cell potential or electromotive force as in EMF. Now, if we can measure this electrode potential in a standard condition like 1 molar concentration, 1 atmospheric pressure and 25 degrees centigrade, then we will call that standard electrode potential E0. Now, not always the conditions are standard. So, to calculate the electrode potential, we have this equation, Nernst equation, to calculate the electrode potential in non-standard condition. So, these are the parameters involved in the equation. Now, if we are given a certain temperature, that is 25 degrees centigrade or 298 Kelvin, then we can simplify this equation to E equal to E0 minus 0.0591 divided by N into log Q. So here I have converted Ln to log and used the value of gas constant and Faraday constant and the temperature as in 298 Kelvin. So this Nernst equation have different kind of applications. Here we will consider three of them. First of all is concentration cell. So if you are asked to calculate the EMF of a concentration cell, this one for example, at 298 Kelvin. So for this cell, both anode and cathode sides had same material. So we can write E0 is equal to 0. So E is minus 0.0591 divided by the here 2 electrons are transferred, so n equal to 2, and log concentration of Zn2 plus from the diluted side divided by concentration of Zn2 plus from the concentrated side, because we will consider this diluted side as anode. The oxidation will happen here, and so we can write E is equal to 0.0591 divided by 2 into log 0.1 divided by 0.001, and this will come around 0.0591 volt. For the second application, we can calculate the equilibrium constant from this electrode potential or cell potential. So for this reaction Fe3 plus to Fe2 plus, we are given the E0 value. We have to find the equilibrium constant at 298 Kelvin. So first of all, that at equilibrium we have E is equal to 0. So we will write E0 is equal to 0.0591 divided by 1, because 1 electron transfer is happening here, into log K, because the reaction is happening that is in equilibrium. So we will consider K, equilibrium constant here, and this K will come around 10 to the power 13 using the E0 value 0.77 volt. Okay, now for the last application we will discuss here is determination of pH. So we know that pH is minus log concentration of H plus, and we also know that the standard hydrogen electrode E0 is 0. So we will write E is equal to minus 0.0591 log H plus, and here pH will come around 3. So this E will use as 0.177 volt. Now let's take the last example, last PYQ for today. For this Daniel cell, we are given the E0 of this cell and we have to find EMF at 298 Kelvin. So here the reactions involved are zinc 2 plus and copper 2 plus to copper. So we can write E equal to E0 minus 0.0591 divided by 2 because 2 electron transfer is happening here, and log, so product by reactant, right? So we'll write here concentration of zinc 2 plus divided by concentration of copper 2 plus. And for the zinc and copper, they are in salt state, so we will consider the activity as 1 for both of them. So now we have this E0, so this is 1.10 minus 0.0591 divided by 2 log zinc 2 plus constant is 0.01 divided by 0.1, sorry, not 0.1, it's 1. So, and this value will come around 1.1591 volt. So I hope you understand the applications of Nernst equation. This you can use in your exam to solve the numerical problems. Thank you for watching today. See you in the next video. Bye bye.